Main lessons for this short talk concerning astronomy, because yes, what else am I going to talk about? People have been pushed so much into black hole, Big Bang, general relativity stuff that it became a fad over the past 40 years. Those are astronomical related matters. Oh, general relativity, the theory of large scale structure. Ooh, black holes, they suck in everything. And ooh, you know, Big Bang, universe just popped into existence. They became quite popular, but as you guys remember hearing me talk about Amasumian back in 1957, astronomy went in another direction, man. Popular culture in astronomy went like this. Any astronomer that's an astronomer these days should be aware of Amasumian's discovery or hypothesis of galaxies ejecting younger galaxies, and Halton Arp's discovery that actually happens. That's what a quasar does. A quasar exits a galaxy and becomes a full-grown galaxy itself, just like an acorn falling off an oak tree. A lot of people these days, they don't know anything about that because they've been misdirected into GR nonsense, to black hole nonsense, to Big Bang nonsense. It's popular, but it's completely nonsense. And I'm not the only one that knows that general relativity is a dead end. The guy that managed the atomic weapon project, the Manhattan Project, Oppenheimer, he also considered GR to be a dead end. I'm going with him on this. If you know how to build something that can destroy entire civilizations, I'm pretty sure you know what you're talking about. Black holes are a dead end, via Stephen J. Carruthers. I'm going with his understanding of it strictly because I understand what he's talking about. And Big Bang is dead end. I want to take the credit for burying Big Bang, but I'm pretty sure somebody else is going to do that. Maybe Mr. Carruthers can do it, but the weakness Mr. Carruthers has is that he doesn't have a replacement for Big Bang, because the static universe stuff it isn't worthy either. Plus, basically you need to replace the Big Bang. If you're going to remove it, there's going to be a giant hole there, so you have to fill it in with something, you know. It would create a vacuum. The theory vacuum, if you will. Another analogy, I guess you could say, is if you have a large city with a lot of people that live there, you just don't blow up all the buildings and then expect people just to move. No, if you take out a building, if you demolish a building, you have to build a new one in its place, because the people are still there. Same thing with astronomy related matters. If you have all those people that study Big Bang supposedly, and Big Bang turns out to be incorrect, where do those people go? They have nowhere to go. Another idea, people are conditioned these days to believe that astronomers and astrophysicists know what they're doing. They don't know what they're doing. The majority of the ideas that they have are made up. And we know this because you can't exactly stick a star in a laboratory. You can't take the sun and put it into a little box and say, look at the sun, we can study it. You know, it doesn't work like that. You have to infer from smaller experiments what you think the sun might be doing. But unfortunately, a lot of the fusion experiments we have, they don't seem to be mimicking the sun's fusion reactor in its core, but everybody knows my opinion on that. As well, a large problem with not being able to exactly take a pulsar or star and put it into a laboratory setting is the fact that we can't watch them evolve. You can't look at a star and say, look, it's evolving, we know what it does. No, you have to take a larger star, a smaller star, a smaller star, a smaller star, and you have to infer how they change over time. You can only infer their evolutionary paths. And my own theory development has to do with inferring that evolutionary path, which includes not only plasmatic objects, but objects which are gaseous, solid, and liquid material. You have to include many phases of matter when you talk about star evolution. The establishment doesn't include all phases of matter. To them, all stars shine, and if it doesn't shine, then it's not a star. It's as simple as that. But that reasoning has led them to a dead end in understanding stellar evolution models, or stellar evolution itself, and has led them to be confused as to how a planet forms, not realizing a planet is an evolving star. It's a very, very old star. Surely we can use some common sense here as to figure out why it is that the Earth's crust is 3.5+ billion years old. Why would it be so old if it just formed out of a protodisk? It would only be a few thousands of years old. Why is it 3.5 billion? Because that's how long it takes for the star to form the crust. Chances are the core of the Earth is many, many, many billions of years older. And considering I've been looking into how something that incredible could form in the center of the Earth, and it is very difficult because there's a lot more to it. It's not as simple as the iron catastrophe where iron just sunk there. For what reason? What heated the iron? What convinced the material in the core of the Earth to move out of the way so the iron could take its place? There's no explanation for that in mainstream publications. It's a dodge, if you will. They say, oh well, it just sunk there because it's heavy. Because of gravity. Ooh, be afraid of gravity. Be afraid of general relativity. No. The iron that forms there, I have to tie into how a star evolves, because when the star is really hot, that iron will collect in the center because of its low ionization potential, meaning it has a very hard time ionizing. It's not easily ionized like hydrogen is. So it's going to be the first material to clump together in the center of a star. And as well, we should also keep in mind that if there's any publications on astronomers knowing what's inside the core of the Earth, well, we can actually infer as to what's inside the core of the Earth by studying meteors. So if scientists say, well, the core of the Earth is really, really dense, it's denser than iron and nickel, so it has to be heavier elements in there. Well, okay, we can kind of figure if that reasoning were to pan out, we should be able to find gold, silver, and heavier elements inside meteorites. But if we don't find them in any large quantity, you can guarantee that hypothesis is false, and there's something else going on here. Maybe the iron and nickel are being compressed to the point that gives them a higher density. Or maybe they're assigning lower densities to the lower mantle, which in reality they have much higher densities. But these are all questions that need to be worked out over time. But one main idea I want to get across to people is, don't pay attention to the black hole. That's buried trash that belongs in the 1960s and 70s with other false nonsense. Don't pay attention to Big Bang. That was already replaced back in the 50s. Before I was even a twinkle in my mother's eye. And general relativity, that's complete crap. It's a dead end. There's nothing you can figure out extra to attach to general relativity. I gave the first 2 years of my supposed researching of scientific matters to general relativity, and there's nowhere to go with that. It's just mathematical nonsense, and it can be ignored. If anything, I think my readers, I know Charles, know about this book, I guess. Read this book. Look at all the ideas in here. Try to find inconsistencies. Try to find where there are questions that need to be asked that are not addressed in this book. As well, if you buy this book, if I start talking about it, I can mention the page, and then boom, you can understand what I'm talking about or where I am. Because there's a lot in here that needs to be learned, and a lot in here that needs to be applied to stellar evolution. And the reason why basic chemistry is important is because, well, astronomers, they think stars are nuclear chemistry, but no, they're not. Nuclear chemistry belongs strictly to galaxies that are active, quasars, and other very, very high energy objects. Radio galaxies, bipolar jets coming out of radio galaxies, that's where fusion applies. Stars, on the other hand, are chemical constructs. They can be explained with chemistry at higher temperatures and pressures, and as well with different phases of matter. Alright, I think I made this video long enough. Today is May 28th, 2015.